Okay, this is Hippo. Today we continue 1A4. 2A4, it is the third class I told about this chapter. So first, as the number of the period increase or as the number of group increase, the highest ionizing energy. So first is the helium because it's in the periodic table here is the helium place. Why? We can hear that because helium just one shell, just have one quantum shell, so it has higher. So first it has higher shell. It is only have one shell, so stronger attraction between the nuclei. And second, in the first shell, it has higher nuclear charge of the hydrogen, so it has higher energy level of the hydrogen. So that's why it's the highest. And third example, why the lithium have less energy of the helium? Because they are different outer shell. Even lithium have higher nuclear charge, but it's not dominant because we say that the energy level is the dominant. It's a factor 2. It's a dominant. Factor 2 the distance, the shells. Okay, if the exam there are only 2 points, you have to say one explanation, but if there's 3 points, you have to say 2 explanations and one is dominant and one is less dominant. Okay, first, the general trend. Some have the same chemical property, down group, some odd electronic configurations. There are more protons in each nucleus, so nuclear charge in each element increases. Therefore, the force of the attraction between the nucleus and outer electrons is increased, and there is a negligible increase in shielding because each successive electron enters the same energy level, so more energy is needed to remove the outer electron. If there are 2 atoms to have a comparison, you have to remind 2. Like this, the magnesium and the aluminium. Look at the configuration. We can find magnesium and next is the aluminium. The aluminium have 3p1. The outer electron of in aluminium is a p subshell. This is higher in energy than the outer electron in magnesium, which is an S sublevel. So S sublevel is going to the magnesium and P is aluminium. We have to remember both of the atoms, so less energy is needed to remove it. Remember, this one shorter distance, higher energy. And third is phosphorus to sulfur. Remind both 2 atoms. We can look here. In the 3p shell, sulfur have electron-electron repulsion. So in the sulfur they are unpaired, but in phosphorus they are unpaired, but in sulfur 3p are paired. There is some repulsion between paired electrons in the same sublevel. This reduces the force of the attraction to the nucleus, so less energy is needed to remove one of them. And fourth, the general trend as you go down the group decrease. Why? Like this one I told in the last class. The valence electrons are in higher energy level, farther away from the nucleus, so larger distance, less energy level, less energy required, remember it. Less energy is needed to remove the outer electron. Even though nuclear charge also increase, the increase of the shielding is more predominant. So it has 3 points. You have to point out which is the dominant. Okay, thank you for us.